So most convex preferences. It's also a technical assumption. Most of the goods are satisfy this property. It basically means if I have two things that are indifferent, and if I find something that is like the mix of them both, I prefer the mix them to the extreme. Basically means that I prefer mixes. Most of the goods satisfy this. I have found very few examples of combinations that are not better than single cases. But there are. Beer and vodka. You could have a good amount of vodka, a good amount of beer, but you probably don't want, or you should not want, to have a complex combination of both. If that's the kind of good, it doesn't really work very well. But it's mostly technical. A convex combination, a non-convex preference yields because it's very poorly written here, or because of the idea it's it's very poorly written here, I realize it. Imagine there are two things that are indifferent. 2 points in the indifference curve. Point A and point B. And I'm going to make a combination of them. Point C. It must be the case that, that my preference is that I prefer C than any other. It's another one. Okay? What? This is convex preference. Non-convex preference will be something like this. Or something like this. Okay, that's the case. That's okay. I still don't know how to. Questions that go so far. So what have we done today? So the first class we talked about rationality. In the second class lecture, we start talking about the general equilibrium model. It's a model where people have an infinite number of people, they're in a competitive situation, and often they're in a competitive situation. We define them as an efficient allocation, and we start with the first welfare theorem. In this lecture, we did the second welfare theorem. The first welfare theorem says that if something is a result of a competitive equilibrium, therefore this allocation is efficient. And the second, now in today's lecture, we're close to the converse of this. It's saying, let's find any allocation that is efficient. An allocation is in the Pareto curve. We restricted our thoughts of fairness to allocations that are efficient. And we stated that we had an example, and we stated the converse. That if something is if an allocation is pretty efficient, therefore we can attain it in a competitive equilibrium with transfers. We just transfer money from people to people, and then they will attain if you make the right choice. The general equilibrium model, this kind of model, is like a tool and yields some nice results. It is still really rely on the fact that we are in a competitive framework here. In the situation that what you do, you are so small that it doesn't matter to me. Here, in no point, remember that I make this kind of a weird story that says, well, Gibrael, there are many people like Gibrael and many people like Saladin, and there are so many that they don't interfere in each other's life. We're going to assume this now, and we're just going to swipe that under the roof for a second, and pretend that this is true. When this is no longer true, when what you do interferes what you do, when we're no longer all of us small people, but we're actually better, we're like major players in the situation, we call this as a game. The situation that what I do matters for what you do. And we're going to play a game now, and I'm going to take into account that you're doing something knowing what I'm doing, and I'm doing something knowing what you're doing, and we're going to when we have this deep knowledge, this common knowledge of this interaction.